Welcome to Learn Biology, and last time we were discussing the properties of water. We left off at high thermal conductivity. So the first thing we have to do is understand what exactly is high thermal conductivity. Well, the easiest way to describe this is saying how quickly heat disperses through water. The key term here is heat. So what this means is that if we have a cup of water, for example, let's just draw a cup with water. Now, let's say we take a matchstick and we place it right in here, right here. Let's just draw a little fire diagram. Okay, and label that fire. If we place that in the water, and this is before, of course, the matchstick or fire would go out, what would happen is that the heat would spread in all directions of the water. Now, what happens in other liquids is that the heat does not rapidly spread out in the water, and certain regions of the liquid heat up fully and create these things called hotspots. Now, hotspots are extremely dangerous for living organisms, especially aquatic animals. If water was, let's just draw a diagram here with sun. If water created hotspots, what would happen is that aquatic animals would go through that water. If this was the water, and we have little fish right here, and this right here was a hotspot. What would happen is that this fish would immediately die. The proteins would denature immediately. So this is an extremely good property of water. So high thermal conductivity is good, extremely good for living organisms, and this is because most organisms are fully made of water, and this prevents them to have certain regions to heat up and cause damage to the proteins within the organism. So high thermal conductivity is an excellent property of water which prevents hotspots, which is a very key term right there, prevents hotspots. Moving on to our next property is high boiling point. Now, high boiling point is again a very unique property of water, and although it is not as high as other liquids, the boiling point of water is 100 degrees Celsius. Now, it takes a lot of heat energy, lots of energy, to convert water to steam. It actually takes 539 calories to convert water to steam at 100 degrees. Now let me just change the color of that a little to make it easier to understand. So again, 100 degrees is a very important term. Takes lots of energy. Usually it is not required to know the exact amount, which is 539 calories, but it's good to know. And this is a very good quality because it prevents cells from boiling. Since cells are made of mostly water, it prevents cells from boiling. So there's not much to say on that. So moving on to the next property of water is high freezing point. Now this is a very bad quality of water because the freezing point of water is only 32 degrees Fahrenheit or 0 degrees Celsius. Compared to other liquids, the property of water, the freezing point of water is very low. If I can bring out a picture right here, a chart, we can compare some of the different freezing points of liquids. So here in the chart we can see that the freezing point of water is 0 degrees Celsius, while the freezing point of other liquids is way lower. Now this is an extremely bad quality of water, because most of our planet is covered with water. Our cells are made of water. Our most organisms on this planet are made of water, if not all. The average temperatures in Antarctica and the northern hemisphere easily drop below 32 degrees Fahrenheit, and what this can cause is for cells to rupture within organisms. So this actually goes against survival for us. All the other properties of water we've seen are for survival. These go against survival. And what exactly is freezing, by the way? It is the slowing down of motion of a liquid in which all the bonds slow down and motion is extremely limited. So thank you for watching, and we'll be coming up with a third video describing the remainder of the properties of water. Thank you again, and see you next time.